Hello everyone, in Poland today we're solving problem 1493, longest subarray of ones after deleting one element. This is medium and the solution requires simple logic. So next I will show you my intuition, approach, and efficient solution. We are given a binary array nums and we need to remove exactly one element. And after removing this element, we need to return the size of the longest non-empty subarray with only ones. So let's say we're given this, and in case you don't know what a subarray is, it's a contiguous sequence of elements. So for example, this is a subarray, this is also a subarray, this is a subarray, but we can't form a subarray with 1 and 1 in this case because these two elements are not contiguous. Now basically we have two rules. First, we need the longest subarray with all ones. And we need to remove one element. So given this input here, we can remove this 0 and return the length for this subarray, which is 3. We are removing one element and the remaining elements are all ones. Now, for example, if we have this input with all ones, we also need to remove one element. So the result for this is 2. Let's say we remove this. This is the remaining subarray. So let's see how can we solve this. Let's say we have a variable which is a boolean, and this will tell us if we have already removed a 0 or not. And this will initially be false. And the result is initially 0, and let's say we start here. We are iterating this from left to right. So given that this is 0, let's say we decide to remove this, so this is now true. Next we are here, so we could think that the result right now is 1. Next we are here, so we could think that this is 2. Next we are here, and given that this is true, now we have a problem because we decided to remove this 0, but maybe we had to remove this 0 or another 0 that we will see in the future. So we are missing something here. We need a way to explore different possibilities because we need to return the longest non-empty subarray. And remember what I told you about subarrays. It's a contiguous sequence of elements. For example, this is a subarray, this is a subarray, and so on. Now let's say we grab this subarray. Here we have a left bound and a right bound. This is a contiguous sequence of elements. So up to this point we have a result of 2 and we have seen the subarray, but we know this is maybe not the optimal subarray. Now we are standing here, we would like to try this 0. So what can we do here to try this new path? Well, if we know where is this left bound, we can just update this left bound one step to the right. So now left is here. And we can remove the 0. And what does it mean to remove a 0 in our state? Well, it means that this boolean is now false again, meaning now the 0 is available. So in case you didn't notice, this looks a lot like sliding window. And here we only need to keep track of left and right bounds, a boolean which will tell us if we have removed a 0 or not, and the result. So let's see the full approach now. We have two pointers, left and right, and they are both initially here at index 0. Initially we have a 0 and we want to explore every possibility for contiguous sequences of elements, meaning subarrays. So that's why we can use a window. We are initially here and this is false, so now we can skip this 0, meaning we can say this is true now. So now the right pointer is here and we have this window. And the size for this window is right minus left plus 1. And this is 2. Now the thing here is, remember, we have removed this 0. And actually we always need to remove one element. Remember, this is one of the rules. Here you can see this. And what this means here is that we always need to subtract 1 from our current window. this has a size of 2, but given that we have removed this, the current size is 1. So now we need to update the result with the maximum among 0 and 1. And this is now 1. Now we update right again. The size for this window is right minus left plus 1. And this is 2 minus 0 plus 1, meaning 3. And we always need to subtract 1, so this is 2. This 2 represents this subarray. Remember, we are subtracting this 0. And the maximum among 2 and 1 is 2, so we replace this with 2. Now right is here and we have a 0. But this boolean is true because we have already removed 1, 0. And we have to remove exactly one element. So this is our current window. And now we need to shrink this. We need to move the left pointer one step to the right. Now before doing this, we need to subtract this from our state. And what this means is now this boolean is false again. So now we can update the left pointer, and this window has a size of 3 minus one element. This is the element we always need to remove, is this 0 in this case, and the result for this is 2. And the maximum among 2 and 2 is 2, so we keep this. And now before moving the right pointer, this is a 0, so we can update this again to true. Now right is here, the size for this window is 4 minus the element we need to remove, this is 3. The maximum among 3 and 2 is 3, so we replace this with 3. Finally we update right, we reach the end and we return the result, which is 3. So the main thing here is to realize that this is a sliding window problem, and whenever right is at 0, for example here, and this boolean is true, this means we need to update the left pointer one step to the right, meaning we need to shrink this window, and we are always removing 1 from every window for the element we need to remove. It doesn't matter if this is true or false, we are always removing one element. If here we have a 1, for example, we also need to remove one element. So the result for this window here will be 4 minus 1, which is 3. And if we have this window, of course we are removing 0, and the size of the window is exactly the same, 4 minus 1, which is 3. Okay, so remember this, we need to find the longest subarray with all 1's, and we always need to remove one element. Time complexity here will be big O of n, and space complexity big O of 1. So now let's go with the code and hopefully you will get the idea. First we say n is the length of nums. Our boolean c for 0 is initially false. The result is initially 0. The left pointer is initially 0, and for right in range n, if nums right is 0, while our boolean is true, if nums left is 0, now we can say our boolean is false, and after doing this we can shrink the window. So we say left plus equal 1. And if we are here, this means that nums right is 0. And if this is 0, after doing this we need to set c to true. Now every time we need to update the result, so this will be the maximum among the result, and the size for the current window, meaning right minus left plus 1, this is the entire size for the current window, but we need to subtract 1 for the element we always need to remove, so we just delete this. And just to be clear, this is we take the maximum window minus 1. And this is because we always remove exactly one element. And finally, we can return result. So this is it for the code. Now let's submit this and see if it works. As you can see, this works and it's very efficient. So if you found this useful, please drop a like, subscribe, and see you on the next one. Bye bye.